Okay, so hello everyone and welcome to Drone to GIS, a joint educational webinar by Sensefly and Esri. Now today's event focuses on using Sensefly drone or UAV data within Esri's Drone to Map for ArcGIS platform. So as such, we'll cover how the drone's images can be processed and integrated within Drone to Map to produce accurate and detailed GIS-friendly outputs. So who will teach us all this? Well, we're going to hear from three experts in their fields. We have Esri's Mark Romeo, Sensefly's Francois Gervais, and a user who employs both Sensefly and Drone to Map for ArcGIS, which is Joseph Adusi of the Argonne National Laboratory in Illinois. My name is Matt Wade. I'm the Marketing Director at Sensefly, and I'll be your moderator today. So let me start by thanking you, our attendees, for joining us. We have almost 800 of you registered for today's session, so it's clear that employing drone data and using that within Esri's platform is a topic that's really of great interest. As you can see then from today's agenda, first we're going to hear from Sensefly's Francois Gervais. Now, Francois will cover the drone component of Drone to GIS, so he'll start us off with a brief background of aerial imagery and a guide to where exactly professional drones like Sensefly's EB Plus fit in. He'll also introduce us to his team's Venoge Industrial Estate Mapping project. And then for part two, we'll move from drone to map as Esri's Mark Romeo takes over. He'll build on this Venoge project data that Francois collected with his EB, and he'll pull that data into Drone to Map for ArcGIS and really show us the detail of how that project's imagery can be integrated and further worked on in the Esri platform. And then following Mark's insights, we'll learn from a real-world power user, Joseph Adusi, and we'll see exactly how and for what purposes Joe employs his Sensefly UAV and how he puts that drone imagery to work within Drone to Map and the wider Esri ArcGIS platform. With all those learnings fresh in our minds, we'll then jump into a live Q&A session at the end, featuring all three of our presenters. And we'll finish off that with a quick final survey for you all to fill in on screen. So just before we get started, then a few quick points about how this webinar will work. So attendees, that's you folks watching, will be on mute throughout the event. However, you can submit questions at any time during the webinar via the question window. And if you can, please do mention which speaker your question is for, and we'll then answer as many questions as possible during the Q&A at the end. If we don't get to your question, as time is always somewhat limited, we'll be sure to answer you personally either during the webinar or afterwards. And during this event, not mentioned in the agenda, we will also have three quick polls, so the 5 interactive questions that you can answer on screen just by clicking. And these will help us and you to learn more about all the people that have joined us today and why you're all here. To answer a common question, this webinar is being recorded for future viewing, and the link to this recording will be sent to you in the next day or so. And then in the coming weeks thereafter, this recording will also be made available for anyone to enjoy on sensefly.com's website. And finally, just a reminder, please also take the short survey that will pop up on your screen as we sign off at the end of this 1-hour webinar. So let's get started with our first quick poll. I'm just going to launch that on the screen. The question here is, what industry do you work in? So this is obviously designed to better understand who you all are, the professionals who've joined us today. So you can just click on the screen to choose the sector that best describes the field you work in. So whether you're in utilities, a government department, transportation, or another segment altogether. We'll just give that one a few more seconds for you all to jump in. And then we'll take a look at those quick results on screen. Okay, so another 5 seconds. Here we go. Okay. And here, let's have a look at the results here. We see that we have around a quarter of you from government sectors, a quarter from natural resources, and a huge half of those from other segments. So feel free to drop a note in the questions there and tell us which segments you work in. We'd be interested to know how that 50% itself divides up. Okay, so let's get our education started by first making sure we understand what we mean when we talk about professional drone technology. So we want to know what this is, how this technology works, and how that can add value to the GIS collection. So Francois, I'm going to give you control of the screen here and you can get us started. So just 1 second and you can take it away. Okay, Francois, over to you.
All right, welcome everyone on my side. Yes, drone imagery or aerial imagery has a long history. It started about 150 years ago. It started over Paris in 1855 with Nadar taking picture from a hot air balloon. And then it went to pigeon, first transporting chemicals and then taking photographs. And then later on glass plate, and then on film until 2005, and then digital since 2002. So a long history, and the idea of bringing a drone for mapping is to make your life easier. How do we do that? Drone operation means no or very little interference with the map site. You don't have to walk in the map site. You can do it from outside. And then it drastically reduced the time that you spend in the field. You spend more time in the office, and it means it's safe, it's comfortable, and in the end, it's more efficient. In the example that we will see today, we have been using the SenseFly EB+. A few specifications first. It has a large coverage because it can fly up to 59 minutes, and it covers at an altitude of 400 feet or 122 meters. It covered 2.2 square kilometers, which is 540 acres, which is a big surface. And one very interesting point when you do mapping and accurate mapping is this high precision on demand. It means that you have the RTK, PPK upgradability that is built in. We will see in a few slides what means this RTK, PPK, but it means that you do precise, accurate work right during the acquisition of your images. And the good thing is you can activate it on demand. So you start with a standalone drone or normal drone and you turn it into a very accurate drone just with a soft activation. And last but not least, the payload, which is very important. Here it's the SenseFly Soda, which is a camera that is designed, that is made for drone photogrammetry application. It means that it's robust, it's stable, it's light, and it takes very nice pictures in many different conditions of light, even if it's cloudy or if the weather is not perfect. The good news is with the EB+, you can add different payloads. It could be a multispectral camera like the Parrot Sequoia or a thermal camera like the Thermomap. Well, we talk here about geometry, and another important point is the temporal resolution of your images. Because any construction site or any mapped area is a changing object. It could change over days, weeks, or months, but it's always changing. So the currency of the data is essential when you need to make decisions. And ideally, the more current is your data, the more effective will be your decision. So this currency is a very important point in the example that we will see together later. And another interesting point is photogrammetry by definition is 3D by nature. It means that any site, and we have a small example here, which is a road under construction, any site is 3D. And the good news is that all your data and then your decision will be based on the 3D information. And I just put next to this real picture, I put the 3D model of this area, and in this image or in this model, you can make measurements. Is it volume, distances, surfaces that are 3D, and they are current because the acquisition has been done just a few days or a few weeks ago. Oops, sorry, it was a little quick. Okay, we will talk about geometric accuracy in this part and in the next part in the mapping process. And we need to have a few, I need to clarify a few acronyms, and I apologize for that. It's a bit technical, but it's necessary for the understanding. First, we will talk about GNSS, and I already mentioned precise GNSS. What is GNSS? It's just GPS, but more general with all the constellations. So it adds the Russian constellation GLONASS, the Chinese constellation Beidou, or the European constellation Galileo. So GNSS is just a more general word for GPS. But anything you know about GPS is valid in GNSS. RTK and PPK, it's an important point already mentioned in the description of the EB+. The K is for kinematic, because everything that we will measure will be during the flight while the aircraft is moving. So everything will be kinematic. The difference is either you do it in real-time kinematic, or you do it in post-processing and you have this PPK, post-processing kinematic. The other two acronyms, I will describe it right now. Okay, we do differential or precise GNSS. What is the difference between standalone and differentials? Standalone GNSS means that you have the accuracy of your smartphone, of your smartwatch, of your navigation system, or your consumer drone. It means a few meters, several feet in accuracy, which is fine for navigation, which is not good enough to make right decisions and to know exactly where things are located. So in this case, you need to turn to differential. And differential means that you will increase your accuracy by a factor 100. You will go from 225 meters to 225 centimeters, from several feet to a few inches. A huge difference. And differential GNSS is just the type of GNSS or GPS that you know, a GPS put on a tripod in the field that is done static or in rapid static. It's just the same in kinematic mode. All right, virtual reference station, what does it mean? There is an infrastructure behind that. There is a network of real base stations. They are not virtual at all. Real base station, but this network is loose, about 30 to 50 kilometers, 19 to 31 miles. And you have this triangle or this triangulation of base station. They are all connected to a server, and this server will deliver to your virtual reference station, and it's why it's virtual. It's a bit foggy because it doesn't exist in such. It's just your laptop or your ground control station that is, I would say, improved by this information, this VRS correction. And then this information is transmitted to your drone that is very close, just between 0 and 1 kilometer, less than a mile away from your virtual reference station. And this is the mode that has been used in this in the particular example that we will use later during this presentation. So VRS, it's a virtual reference station that makes your drone like being linked to a real base station next to you. This is the first option. The second option is what we call the CORS, the continuously operating reference station. And in this case, it's something that is good for PPK. And remember, PPK is in post-processing, so it's not done in real time. It's something that can happen after the flight, and you can decide to do it or not after the flight. And in this case, you will connect to the real base station with a distance of several kilometers. You can see here 12 to 12 miles away. You still have your network of real reference station that is working for you during the flight, and you just connect in post-processing to this base station. Again, this can be done, previously it was in real time, here it's in post-processing, but it's still kinematic, the reason of the K. Last but not least is if you have your own base station, your own real base station, and it's set on a tripod and it's connected to your laptop with the wire or wireless, the Bluetooth, for example, makes a great job here. And then, so you have your laptop and you have the link to your drone, and again, very short distance between 0 and 1 kilometer during your flight. So quite interesting, your base station in this case can be set on a known or an unknown position. So you don't need to be on a particular point, on a materialized point. It could be anywhere, and you do the link with the real world afterwards in post-processing. Good. So as mentioned, we will discuss this Venage data set that has been shared, that has been acquired by SenseFlight, and it has been processed by Esri in Drone2Map, and it will be presented in detail by Mark in a few minutes. It's an industrial estate, and it's quite interesting because it's typically changing a lot over time. And in a few months, there are new roads, there are railways, there are buildings, and the site is changing. I mean, the nature is changing, of course, but here, week after week, month after month, we can see all the changes on this particular site. A few flight characteristics. So as mentioned, EB Plus with this precise GNSS activated, and we were with this virtual reference station, the sweep pause service that was used here. The surface 68 hectares, 168 acres. Nice area, not big, not small, just perfect to be done in a reasonable flight. It's 2 kilometers in length, so it's perfect. If you sit in the middle, you are never too far away from your drone. You can keep an eye on it, so you are in visual line of sight all the time. The sensor used is a SenseFlight SODA, so this 20 megapixel. And it makes a nice footprint of 150 meters by 100 meters on the ground. Resolution, we flew exactly at 400 feet, and means 122 meters, and we have a resolution of 2.8 centimeters, 1.1 inch, which is fantastic to see all kind of details, and we will see plenty of them in the next slides and during the presentation later. Overlap, typical, so the longitudinal 75%, which is very traditional in the digital photogrammetry now, and lateral 60%. 16 lines fitted to the topography. It's a bit hilly, you will see in a few seconds. Flown in July, perfect in solar midday, so perfect light condition. 43 minutes of flight, 592 images, nice flight, and very important, the RTK success rate. 99%. It means that we are almost perfect. You will see that out of this 500, almost 600 images, only 6 were not with the highest accuracy. All right, let's see very quickly if I can move. Try to, yes. Let's see the situation. So you have the area here, this 2 kilometers in length, 500 meters in width, and we can see the 600 images, and you can see the trajectory, so the drone taking off from the middle of the field, doing the 16 lines autonomously, coming back and landing, and this is it after 43 minutes. What is the content of the images? As mentioned, there is a railway on the side, there is earthworks everywhere, there are constructions, buildings, cranes, vehicles, and it's all kind of interesting buildings that we will be able to see in a few seconds in the next part. And landing, your images are geotagged precisely because we went RTK. RTK was successful. So we have now 592 images ready to be processed in Drone2Map, and this is where Mark from Esri will take over. Before that, I totally apologize for that. The very important point, I mentioned it orally, the geometric accuracy must be assessed in this part. And you have this little statistic as the last part of the software mentioning this, the 99%. It's not out of nowhere. It's a statistic that comes from the software telling you that your tags, your geotags are accurate, and you have this nice number, the 6 images that are slightly less accurate more in the feet, 4 feet accuracy, and this won't impact at all. I mean, we have plenty of accurate images, and we are right in the specification, as we say, between 1 and 2 times the GSD. Remember, the GSD is 2.8 centimeters. We are right there with 3.7 centimeters. And again, PVK would have been possible if necessary, but it wasn't the case here. So now it's really the time to pass over and process this data.
Great. Thank you very much, Francois. I think that's a really useful, great context for the talks that are going to follow. And don't forget, if you did have any questions for Francois during his presentation or about what he's presented, do just drop those in the question window, and we'll be sure to try to answer those with Francois at the end. So before we crack on to the next presentation from Mark, let's just do another quick poll. The question this time, what is your usual source of geospatial data? So on the assumption that our attendees are generally working in the GIS sector, how are you collecting that geospatial data that you use today? Is that through satellite imagery? Is it through manned aircraft you're hiring? Or is it a certain type of drone, maybe a fixed wing like an EB or a multi-rotor, or are you using terrestrial survey data? So let's just give that a few more minutes, a few more seconds, and then I'll share those results with you on the screen. So if you didn't click your choice there, just click that now, and we'll close that up. We'll take a look. Okay, let's close that. And you can see from the details here, really interesting results. So around a quarter of you using satellite data to work with. Significantly less than that really on the manned aircraft. And then probably almost getting on for half of you in total using some form of drone today. Obviously a choice of fixed wing or multi-rotor, maybe I would guess depending on what size of sites you're looking to cover. And 1 in 5 almost of you using terrestrial instruments and surveying to get our data. So that's great. Let's move on to our second speaker now. And this will be over to the Esri side. This is Romeo, who's going to continue Francois' Venoge project example and really take us into the drone to map for ArcGIS workflow. So Mark here, I'm going to make you a full presenter so you can show us your live demo there. And just give me 1 second. I'll click over and you should be able to take it away.
Okay, I can hear you, but I'm not given the option to share my screen at the moment. I've got a notification that says the organizer must hide the poll results to enable screen share.
Apologize then. There we go. You should have it now.
Okay, I'll let you give me the thumbs up when you can see my screen.
Yep, that's great, Mark. We can see it on screen now, so take it over. Thank you.
All right, well, thanks. Again, my name is Mark Romero. I work for Esri on the imagery team, and I'm going to show you some workflows working with drone imagery using ArcGIS. And so the app that you're looking at on your screen right now is Drone to Map, and I've already preloaded a project. And I've already loaded all of the 592 photos that are part of that Venoge data set that Francois just talked about on his slide. The only requirement before you get started when working with Drone to Map is that each of the photos are geotagged. And you can see the photos listed here with their lat long and altitude. And that's just the GPS location that was captured by the drone itself. So I can immediately hit OK there. And what's going to happen is all those photos that are part of this project are going to be loaded directly into the map. Drone to Map is integrated with ArcGIS Online, so any of the content that's part of ArcGIS Online is also available to you. So you can see as I zoom out here, we can see the world base map content. Just as a QC step, you know, one of the things that we recommend is just simply clicking on the photos and making sure that there's no blurry photos or any photos that might affect the processing. And so this gives you also a good sense of the resolution and the quality of the photos as I click the blue dots. Now, I can also look at the image properties for each one of these photos. Yeah, because these were captured using the EB Plus with the RTK system, the accuracy both vertically and horizontally are listed in here as well. And so I just wanted to point that out. And normally when you don't have a system with an RTK built in, you're not going to have these additional parameters on there. And these are just used by a drone to map to be able to properly calculate and come up with the product at the end. Another workflow that we have in here, and this isn't again necessary for this particular data set because these are already accurate enough where we're not going to need a ground control workflow. But what I did want to show is the ability for drone to map to work with ground control points if you do happen to have to collect those. And so I ran a different version of this project with the ground control points, and those are represented by those red X's there. And again, I'm not going to run this project with these just because it's not necessary. But if you do need to bring in your ground control points, there's an entire workflow for linking each photo to that ground control point on the ground. And so you can see that there. And so once you've processed your ground control points or you've ingested your photos in, all that's left to do is kick off the start button. And so I've already ran this project, and so let me just show you the results. Okay, so let's turn off my GPS points, turn off my flight lines, and then also turn off the contours. And so we'll zoom in just to give you guys a sense of the final product here. This is the ortho mosaic that you're looking at now. You can see there's a lot going on in this project here, a variety of different features to work with. And so we thought this would be a good data set to show. And very quickly, you can see the terrain behind it. And this is the digital surface model that's generated from the process itself. And again, you can see the amount of detail that's a part of this area of interest here. We also have the capability to do a digital terrain model. This is an estimation, just so you know, but drone to map does also output the DTM. Now, drone to map is primarily designed for the processing side of things. If you're going to go into deeper, richer analytics, that's where ArcGIS Pro or some of the desktop tools come into play. However, there are built-in to drone to map a few tools for doing some basic visualization and analysis. So in this case, what I'm doing is just calculating a simple volume of that stockpile. And so we can let that process. We also have some markup tools, a variety of different measuring tools. And then in addition to that, what I really wanted to share here is because drone to map is tightly integrated with ArcGIS Online, there's no need to go outside of drone to map to be able to share your content up to the web. And so if I wanted to share any of the imagery or the 3D content, I just click these buttons. I'm logged into my ArcGIS Online account, and then I can just select the products that I want uploaded. And that works for both 2D and 3D. And so here's the results of our volume calculation. So one of the layers that I've already shared up to ArcGIS Online is the 3D textured mesh, as well as the point cloud. And so here's just a quick view of the textured mesh that's generated directly in drone to map. All of these products can immediately be uploaded to ArcGIS Online. So I've just switched to my web browser, and what you're looking at now is not the textured mesh, but the actual point cloud. So within ArcGIS Online or ArcGIS Pro, you can take the point cloud and convert it to a format that's optimized for streaming point clouds on the web. And you can imagine how dense these points are. And the performance is very good because the product is actually indexed into a web optimized format. So we're looking at this product point cloud with the RGB values. And so we'll just look at a couple different views here. And so you can see once it displays once, it's kind of cached and it's now performs very well. The other capability that we have within the web environment, working with point clouds, is we can configure this layer and view it in a couple different ways. So right now we're looking at it based on the RGB values, but I can also switch to elevation values. And what that's doing is re-rendering the product and showing it by height. So the darker red values or colors represent higher elevation values, and the lower, cooler ones represent the lower values. So we're looking at this bridge deck under construction. I can click this options button, and if I wanted to actually query or maybe find certain values of certain heights, I could do that directly from the web. And so I've got this nice little histogram here that shows that the different values and how many of the points fall within a certain range. And so, for example, if I wanted to find only the values that had that fell between 403 meters and 418 meters, I can adjust that slider and then begin to adjust those values and find where those at. Or if I was interested in maybe only values that contain buildings of a certain height or values of a certain height, I could again, I could query those. And so you can see all these different red values up here are the highest ones. So I just wanted to point out that we do have the ability to work with point clouds on the web. So now what I want to do is I want to switch from the web, and I want to switch over to ArcGIS Pro. This is our flagship professional GIS application. Now, one of the challenges when working with point clouds derived from photogrammetric processes like drone to map is the points are not classified. So we can see the values by height, but unlike traditional LiDAR, if I wanted to view the points by classification like building or ground or some of the other categories, I couldn't do that unless I've gone in and manually classified these. And so within ArcGIS Pro, we now have the ability to take an unclassified point cloud. It doesn't matter if it's LiDAR derived or photogrammetric derived. And we can run it through a set of tools that we have for classifying the different types of categories. And these are listed here generally in the order that you would want to. So I've already gone ahead and done this. I've classified the ground. Those are indicated by the brown points. Classified the buildings, which are indicated in red. And then I've also classified some vegetation in and around the area. But often you're going to have to work with values that are completely unclassified. And so one of the workflows we have is to be able to generate building footprints from unclassified point clouds. And so the workflow is based on the geoprocessing model. And we have a whole set of tools that are follow along. And these are publicly available. For the sake of time, I don't have, I can't run through each one of the tools, but I did want to walk through kind of the process here. But it basically starts with your unclassified point cloud. You generate a DTM and a DSM. You apply a couple of filters, and you can see when we start applying the filters, we can just start to distinguish or extract out certain characteristics or objects within the feature itself or within the image itself. We can then apply some additional filters. In this case, this is a multi-directional hillshade. And then once we have that, we can make a binary file that just basically has zeros and ones, and the ones representing the outlines of the buildings and certain textures. And at the end, what we end up getting are some raster building footprints that we can then vectorize. And then what we get is kind of like a generic building footprint layer. And so that's nice to have, but then what do you do with it? So I want to go back to the web here, and I just want to highlight this local government 3D base map workflow. This is a workflow that lets you take generic building footprints, combine that with a point cloud to generate some roof forms. And again, this is an established documented workflow that we have. And so I've taken this Vinoj data set, generated this building footprint layer that you see in red. I've run it through the local government workflow, and so you can see the point cloud there. I've then taken that building layer, used that as an input to classify the points as buildings, and then with those we can easily generate actual building footprints. So what you're looking at here are the actual building footprints that I've gone through. And at the moment here, these look like just you know, bricks or rectangles. There's another workflow that's part of the local government solutions that's factors in the pitch of the roofs and lets you really get a more detailed or more accurate representation of the building model. So just wanted to walk through those. These are some fun workflows that we've really been working hard on establishing for customers that have point clouds that work with LiDAR data and that want to do more with the information. So these workflows are really all about maximizing the value of your drone imagery and actually doing something with it. So that's going to conclude my demo. I'm going to go ahead and turn it back to you guys.
Great stuff. Thank you very much, Mark. So if you have a question for Mark, folks, don't forget, just type that in the question window, and we'll do our best to answer as many of those as we can in the Q&A at the end. So before we move on to Joe, we'll just run our third quick poll. So I'll just open that up on the screen, and you guys, just like before, you can answer that just by clicking on the screen. So here, this time around, we're looking to learn how timely the data you're working with is today. So are you working with data that's a few days old, weeks old, maybe even months or years old? So we're interested in that currency question here that Francois was talking about before. So just click on the screen and let us know which one of these kind of best represents the currency of the data you're working with. So we'll just give that a few more seconds, and then we'll check out those results on the screen. Here we go. So let's close this up. Last clicks. Okay, we're closed, and what we're finding here, you should be able to see on the screen now, is that fairly ahead with 34%, you're working with data that's a few months old. And then a quarter of you, much more current data than that with a few days old. And only 1 in 5 of you working with really what we might term older data of a few years. So let's move along, and next up, I'm delighted to introduce Joseph Adusi of the Argonne National Laboratory in Illinois. Now, Joe's going to give us a flavor of how he combines SenseFly and Esri technologies to create new knowledge in his field of homeland and national security. So, Joe, if you want to unmute yourself, I will just give you the keyboard and mouse, and then you should have that right now, and you can take it away. Thanks, Joe.
Hi, everybody. Thanks for having us today, too. We're delighted to be on board here. I'm Joe Adusi from Argonne National Laboratory. I've got my colleagues Rob Landers and Eric Swanson here as well, our two UAS pilots as well. So if anybody has any aviation questions, too, we can answer those. Quick background on Argonne, and I'm advancing the slides here. There we go. So I'm going to go back one. All right, so Argonne National Laboratory, we're about 20 miles outside of Chicago, Illinois. We're a research laboratory for the United States Department of Energy, about 3,500 employees. many scientists, postdocs. We do some great science work along with our sister labs across the country. We're lucky enough to be integrated into the UAS program here at the lab. And we're going to go through some of the missions that we are accomplishing here at the lab and some of the research we're doing. I'm forwarding a slide. There's a little bit of a delay in the slides here. Could somebody advance the slide for me? There we go. So one of our missions here at Argonne is applying Homeland and National Security applications to small UAS devices. And our thoughts and our research is primarily dedicated to looking at having UASs perform operations that are particularly, as we like to say it, dirty, dull, difficult, or dangerous. If we're going to have law enforcement or first responders or people fighting a forest fire or first responders in a flood going to the field, we saw immediately and early on small UASs as having these machines go in and doing the jobs that humans used to have to do, or replacing some of the larger fixed-wing aircraft or satellite systems that might take days or weeks to actually deploy to a disaster area. So we're concentrating on the Homeland Security and first responders aspect of these machines. So again, putting these UASs at risk over a fire, over a flood, over a hazmat spill is much more enviable to us than putting humans in these positions. We see the evolution of first responders, rushing into a scene as being something that we hope to put in the past. We hope to put UASs out in front and putting these drones in with different sensors to both collect and map these data sets. So we see this as a unique opportunity for us to look at infrastructure. So here at Argonne, we're in the Risk and Infrastructure Science Center. So we see this as an opportunity to look at critical infrastructure after an event has happened. So for instance, we do a lot of work looking at water towers, post-earthquake, post-flood, post-incident. It's one of our missions is to go and assess the structural integrity of these. So we've had a lot of practice going in and looking at objects like that, objects such as water towers, bridges, for instance, electrical transformers and substations. So we're getting a lot of practice looking at these with UAS aircraft and multiple sensors to assess the relative health of these infrastructures. So moving on here, you'll have a bit of a delay. So again, we're looking at Argonne here, both the positive ways to use UASs and map these results in terms of infrastructures, but we're also looking at the risks that these may pose to first responders as well. So we see, a lot of times that people who have not so good intentions could actually use these aircraft to perform reconnaissance, to actually use kinetic weapons on them and such. So at the lab, we're looking at ways to detect these and identify these early on in order to potentially mitigate that threat. So we're looking at data analytics as well, which is where the drone to map comes in with the sensors that we have on these aircraft. So we are into high performance computing and looking at the what my colleague Mark was just showing you in drone to map. We're interested in performing that process as quickly as possible. Sometimes it can be a little painstaking when you gather large amounts of data and big data sets. It's painstaking to run it through only to find maybe there's an error in your data or you didn't process exactly what you wanted. And as a lot of us out there know, it could be painstaking to run through a process, have it run for 5, 6, 7 hours in some instances when you're doing an intricate 3D model, only to find that you skipped one part of the process, or you had bad data, or something happened. So one of our goals is to reduce that time, that whole processing time, into, we hope minutes instead of hours sometime to get those results not only rendered faster, but to pass that along to the decision makers and the people on the ground who need to ingest that ground intelligence, that field intelligence, in order to keep people safe, to save money, lives, safety, all that good stuff. So moving ahead here. U.S. equipment. We have a very large aviary. These are a couple examples of what we have. You're looking at the EB in the upper right. We're looking at our multi-rotors in the lower left. The lower right We have some work that we've done in the past with the Air Force. We have some Air Force fellows who come to Argonne and spend a year doing research with us. And what you're seeing is a 3D printed UAS that was printed by a commercial off-the-shelf parts, and the frame and the engineering was done in-house, basically on the back of a napkin by one of our partners and printed on a 3D printer. In the upper left-hand corner there, you're seeing some arrow points. So when Mark was talking about ground control points and Francois was talking about the ground control points, these are some of the ones we use to verify how accurate our data is. So as you see, using the EB and the Albris, we gather this information quickly, and we want to gather as much data as accurately and as quickly as possible. And using high-performance computing and the best practices, we want to render that data as quickly as possible and redeploy it back to the field elements as they were showing through AGOL and other methodologies, and sharing that with people in near real time. So moving on. So we do emergency response. So we've done a lot of training, we've done a lot of filming of exercises, and what we've seen is that a UAS allows us to go in and map out these events and film these events in near real time and stream or telemeter that data to the decision makers in, very quickly. And we see the need for mapping as one of the basic concepts. A lot of times what we've encountered in our work is that people just film. They want to run video on fixed-wing aircraft, on rotary aircraft. They just want to film an event like a TV coverage, which is fine, and it's very important. But we see a gap in there that I believe Drone to Map fulfills, which is recording that instant in time so you can do change detection on that data sets, whether it's a flood, a forest fire, hurricane. If you're looking at multi-spec data, you can look at the relative health of power stations, substations, record that in time. And as the processing time diminishes and gets less, we can fly more and more missions to look at that change detection. So instead of waiting for large fixed-wing aircraft to get deployed to a site, you get it set up, fly the mission, post-process the data. It takes weeks sometimes, even months. When I was in local government, we'd wait for, sometimes months for the post-processing of our county ortho photos. Now we hope to reduce that time frame to, minutes and hours instead of days, weeks, and months. So again, the need for mapping, I think, is a huge gap that is quickly being closed with the advent of these products that post-process this data in all sensor types. So you talk about multi-spec, infrared, EO imagery. The Drone to Map product does process that, and it's doing a wonderful job doing it quickly. So next slide here. One of our missions that we've encountered is training first responders in how to use these new aircraft as a tactical advantage in their missions. So at the College of DuPage, right outside Chicago, we have a Homeland Security Education and Training Center. Argonne partnered with the college and put a class on in June of 2017 for law enforcement and first responders. Now, the class focused on passing the Part 107 exam for these first responders. And, our instructors did a wonderful job here of having the participants pass the test. But we also had them out in the field flying these aircraft and getting tactical experience with these aircrafts, not just putting it up for the sake of putting an aircraft in the air, but also to use it in their day-to-day tactics. So what we found was very beneficial to us was looking at and examining how these first responders would possibly use these in their day-to-day activities. So one anecdote we'll put out there and share with everybody is one of our law enforcement officials was there, and he had played around with a personal UAS in his day-to-day activities. So he went out there and responded to a what they thought was a suicide in the middle of a forest. And there was an individual in a vehicle who had apparently committed suicide in the middle of the forest. They went out there and treated it just like any other investigation they would do. But this official decided to put a UAS up in the air and kind of film it from above just out of curiosity. And what they saw was that there was a second set of tire tracks actually entering the forest from a different direction that they might not have seen had they just used ground-based, their visual senses to look at the scene. They went back and reassessed the situation and saw that there was a potential second vehicle that had come in there. They would have never gathered that intelligence or information had they not used an aircraft. So that was a good lesson for us, that you might not be looking at a crime scene the same way you would if you were only using your eyes. So again, here's some examples of some infrastructure mapping we're doing with the tools that we've talked about. We enjoy using the RTK EB quite a bit. It's been a wonderful addition to our aviary. The processing time goes down tremendously with accurate imagery. We do use the control points quite a bit. But honestly, when we use some of the aircraft, they're getting so accurate that it's just a measurement of how accurate our initial data is becoming. So we're looking at some rooftops there with some infrared imagery. We're looking at some 3D rendering and just some really good EO imagery in the lower right-hand corner there. That was processed. This in the lower right was an EB RTK. So moving through this. Again, here's one of our missions that we flew over just a park, just a softball field, using drone to map and the EVs here, and it was remarkably quick. The flight in of itself took, I want to say like 8 to 10 minutes. It was a remarkably quick and quiet flight. The EV is a wonderful aircraft. You can barely see it in some sense because it looks like sometimes like a bird of prey, like a raptor. It's quiet, it's fast. You can land it in a bandbox. I'm a big fan of that aircraft. So there's our flight. We post-processing, we look at this data, and it's just remarkably accurate how small, how resolute we can get this imagery down to 1 inch in that amount of time, and the processing time is cut down to almost nothing, running the same 3D images and digital terrain models and digital surface models that Mark was showing you before. And as you're seeing from these numbers down here, the accuracy is just incredible. So we're a big fan of using these UASs to quickly map, render, and share this imagery throughout the industry. Through here, we like to use the communications aspect of this. We like to share this with potential people who need to ingest this information. So what you're seeing here is some sharing of the screen that we use between people who need to ingest and see this information as the flight is occurring, and our pilots in the field, and maybe intermediaries. So we enjoy broadcasting our flights so that people who need to see this data can actually interject their own opinions from remote places. So people might be 1,000 miles away. We're sharing with our pilots in the field what they're seeing in e-motion here. So it's a really good tactical advantage to screen share what our pilots are seeing with the people who are going to be making decisions. Maybe they're subject matter experts in water filtration. Maybe it's a bridge engineering expert. Maybe it's somebody who knows water towers very well, or structural engineering, or forest fires, you name it. Intermodal facility experts might be looking at what our pilots are seeing remotely and guiding the flights, and it reduces the amount of time and the number of times we have to go back to the field to fly this imagery. So it's getting a second, third, 100 set of eyes on the same problem if we need it. So with that, I'm going to turn it back over. We'll field any questions you have, but thank you for having us today.
Great stuff, Joe. Thank you very much. I hope you find that on the ground kind of detailed insights as interesting as we did. I think that's a really useful look from both Joe and Mark at how this drone data is being implemented into the Esri platform and how it's been used out there in the field. So now we've heard from all three of our speakers, we can move into the Q&A section of the webinar. So our team here will keep monitoring any new questions you add in the question box over the next 5 minutes or so. But we'll start by getting started with the most pertinent of those that you guys have asked already. So let's get started with a question. Well, actually, a few people asking about the recording of this webinar. Just let me clarify that we are recording the webinar, and there will be an automated email like the one you received when you registered that will go out in sometime in the next 48 hours, and that will have a link to the full recording of the webinar that you can then watch again or share with colleagues. Okay, so let's start with the questions here. A question from, let's see, Dave Mann is mentioning a question about the UAV's attitude, so the pitch, roll, and heading. How important is this? Maybe this will be one for you to answer, Francois.
Yeah, thank you. Thank you for the question. Yes, it's important. It's measured. It's something that is used. I mean, geolocation XYZ is essential, and then this information will be used just to set the block, to speed the processing, and to make the reconstruction faster. It doesn't need to be extremely accurate, but it is part of the georeferencing. There is the geolocation, which is XYZ, and there is the attitude, that both are recorded in the metadata of the image. So it is there. It wasn't shown, but it is there in the processing, yes.
Great. And our second question here from Juan. How long is the processing time for a particular area that you've mapped with the drone? So let's say 20 acres. How long does that take to process? And then can you use drone to map without the internet, or do you need to be logged in and connected online? Maybe some questions for you, Mark.
Yeah, I'd be happy to take that one. Processing time, I'll just say, completely varies depending on your hardware. So if you have a beefy machine with good CPU and GPU, drone to map will take advantage of that. So the more CPU you have, the faster the processing time, the better quality of the GPU that you have. That also plays into like the processing early on. So yeah, just mine took on an Amazon machine, that Vinoj dataset, 592 images, took about 6 hours, but that's a 40-core machine. It's as good as it's as good as AWS can give you. So on my laptop, that would probably take close to 16 to 20 hours. And second part of the question, could you repeat?
Sure, yes. Let me double check. The second part was whether you needed to have an internet connection and be logged into Drone to Map to do the processing.
You initially need to be logged into your ArcGIS Online account, because your ArcGIS Online named user is your license manager. However, you can check it out for offline use, so you don't have to be connected to the internet. To process, you just need to make sure to plan ahead, if you're going to be disconnected, to check out that license and take it with you.
Okay, great. The next question here, I think, is probably one for Joe. We have Jeff Burns asking Joe for what's the latest on the FAA clearance for drones to fly autonomously and beyond visual line of sight. I wonder if you or any of your colleagues there have any insights onto that.
Hi, this is Joe. So I'm going to turn it over to Eric Swanson, one of our pilots here, and one of our Part 107 experts to answer that question. Eric.
Hi guys, this is Eric. So the FAA is currently working with a number of individuals and experimental projects through the Center of Excellence, as well as a number of waivers with Part 107. In a limited number of cases, the FAA has actually approved operations for beyond line of sight. However, the majority of these have been in areas of where you truly would consider that not to be congested. So over in urban areas such as a city and a town, or any kind of a populated area where I would imagine the majority of your use case would be with the small unmanned aircraft system. That in itself is something that is still being worked on, but it is not. It has not been finalized yet, because a lot of the standards related to these systems have not been ironed out, not only here within the United States, but also around the world when you look at ICAO. So it's kind of a push and pull. The FAA needs more data for this. So I think definitely in the near term, it's going to be coming down the pipeline. I just can't guarantee any kind of a date. So, but definitely for sure, there's a number of things that you can get involved with. If you reach out to the FAA, they might be able to help you with getting your approvals as necessary.
Thanks, Eric.
Great, thanks very much. Question here from Aaron Shaw asking about the drone itself, asking can the EB be fitted with different cameras, for example thermal or infrared cameras? Aaron says he could see how this could be used to help, for example, find lost hikers in an area if the processing could be done quickly enough. So Francois, maybe you could give us a bit of a sensor overview there.
Yes. Actually, yeah, the EB Plus can carry a multispectral camera, the Parrot Sequoia, or a thermal camera. So you can do exactly the same mission like the Venage example. Just if you need the thermal images, you will need to fly it a second time for the thermal. But you could do exactly the same processing. And by the way, the PPK, the precise GNSS in post-processing is available as well, because the GNSS is in the drone and not in the sensor. So the positioning of the sensor will be provided by the drone. And some examples that were presented by Joe were from the multi-rotor system, the Albris, and here you have all RGB, high-resolution RGB, and thermal images overlaid that is available in real time. So it's a different application. I mean, it's in video. You can overlay the thermal information on top of it. So it's slightly different if you are on the fixed wing or if you are on the multi-rotor. But yes, thermal and multispectral for agriculture, for example, is possible as well, the same way like it was presented.
Great. And there's Tony here asking, I guess a question for you, Mark. Is ArcGIS Online required to use Drone to Map itself?
No, you don't have to use ArcGIS Online. However, the way that Drone to Map is licensed is through a named user, and a named user, you have to have a named user account in order to license it. So ArcGIS Online's username model is these named users. So whether you use ArcGIS Online or not, you have to have an account to run Drone to Map. That's just even if you only use it as the license manager. But it doesn't need to be present for you to operate in and out of Drone to Map.
I see. Great. And I think one final question for you, Francois, on the drone side. Orbin Dorion is asking, does the EB itself have the ability to follow the terrain when it's doing its mapping flights? So in order to get a consistent resolution over the landscape, is that something that's included in the UAV?
Yes, it's part of the planning, and for that you will use the Emotion 3 that is built around 3D. So you will have a digital surface model as background, and you will set your lines according to the topography of the map area. So all the lines will be will follow the topography, and you will just put in the right direction so it can nicely follow the topography. But just remember one thing: we usually the rule of thumb is to be accurate in height with at 10%. You have a buffer of about 10%. So if you fly like in this case at 122 meters or 400 feet, you have a buffer of plus minus 40 feet or plus minus 12 meters. So it means you don't need to follow any small hills or small undulation. So you will just put your lines according to this 3D model that you have in background that you can display, and so you can fit your planning in your planning software, in the Emotion software that has this 3D option to validate your flight before it is flown according to the terrain. Yes.
Great. And let's finish off with a question here about a drone to map side. So Jesse is asking a question for Mark. Are there tools within drone to map for editing the ortho mosaic that you produce from the drone flight? So Jesse's wanting to know if he could edit problem or misbehaving zones within the ortho imagery. So I guess a question for you, Mark, or Joe, if you have any experience of doing the same.
No, you cannot do that directly in Drone to Map. If you wanted to do that workflow in ArcGIS, you would create a mosaic data set of all the ortho mosaic tiles that are written out on disk. And so if you navigate down into the folder structure of your project folder, you'll see in another folder called 2D, all the different tiled products, so the tiled orthos, the DSMs. So you can take those individual tiles, put them in a mosaic data set, and a Mosaic data set has seam line generation, and so you could bring in those seam lines. That would be the workflow I would take, but not anything like the equivalent of Pix4D where you can kind of edit those different segments.
That's been our experience as well. I'm glad you answered that, Mark. That's the same answer I would have given.
Great. And just before we close, I see a new question as well here from Eldred. I think for you, Mark, as well. Say, will the toolboxes and the workflows for building footprints be made available, or are these available already?
Yeah, they are already available. Yeah, I would have to give you the links, or you could reach out to me directly. I don't know what you guys suggest for reaching out, getting links to the attendees, but yeah, they're all very well documented, and they're publicly available. They're downloadable. Just would need to get you the links. So my email is mromero@esri. Are there going to be some follow-up notes to this webinar?
Yeah, that's right. So what we'll do, Mark, we have an automated email that we can edit that will go out with the recording for the webinar. So if you could drop us 2 or 3 of those most pertinent links, we can edit that into the email so everyone gets those and they can see what we've been referring to and play around themselves.
Perfect, sounds good. And we also have a free workshop that walks through those processes step by step, and I'd be happy to point those out to you guys.
Yeah, that sounds perfect. Okay, so that one there will be our last question. And on behalf of SenseFly and Esri then, I'd like to thank all our speakers for all their time and for sharing their experiences. We do appreciate it, and we hope you all found that very interesting. And to you, of course, for taking the time out of your day to learn more about the drone to GIS workflow. Now, one final reminder just before we go, you will see a short survey pop up as soon as we sign off. That will also be mentioned in the follow-up email, so thank you in advance for giving us your feedback there. And we hope to see you in another SenseFly webinar in the near future. So thank you again, and goodbye.